In this video, we will be discussing homogeneous differential equations. So homogeneous differential equations are the second type of differential equations, ordinary differential equations. So we will be using this if the variables cannot be separated by factoring, so meaning it cannot be solved by separation of variables. And another condition to successfully use the technique for homogeneous differential equations, we should have the same degree of the variable coefficients. So once we satisfy those conditions, next is for the solution. So we will substitute y is equal to vx or x is equal to vy, depending on which substitution will give us the easier solution. And then the resulting differential equation should be variable separable. And then once we have solved the differential equation using separation of variables, then we will return it to the original variables. Okay, so say for example, so we have find the general solution of x plus 3y dx minus 2x dy is equal to 0. So as you have observed in this problem, x and y in here cannot be separated. Okay, so therefore we cannot use variable separable in this problem. So since this is not variable separable, then we should think of another solution that may solve this differential equation. So the second solution that we think about should be if it is homogeneous. Okay, so to test if it's homogeneous, then we will look at the variable coefficients. Okay, so x, y, and x. So we look if its degrees are the same. Okay, so for x, degree is 1, y, the degree is 1, then x here, the degree is 1. So therefore, this is a homogeneous differential equation. Okay, so now that we have verified that it's homogeneous type, then we will substitute y is equal to vx or x is equal to vy, again depending on which one would give the easier solution. So let's try the two. So if we let y is equal to vx, then dy using the product rule will become v dx plus x dv. Okay, and then if we let x is equal to vy, then dx is equal to v dy plus y dv. Okay, so in substitution, so why is it that y is equal to vx is easier? It's because if we substitute dy in here, then we only need to distribute 2x with v dx and x dv. On the other hand, if we substitute dx, then it will be more, the solution will be more difficult because we will distribute x to v dy and y dv, and also distribute 3y to v dy and y dv. So therefore, it's easier to use y is equal to vx. So if y is equal to vx, so we will use this. If y is equal to vx, then x plus 3, then y is equal to vx. So 3 vx dx minus 2x dy is v dx plus x dv. And then is equal to 0. Okay, so before we proceed, so for homogeneous linear differential for homogeneous ordinary differential equation, so after the substitution, there must be some variables that should cancel out. Okay, so in this case, we can cancel out x because for the first term, x is a common factor, and then here we have x. So if we factor x, then what will remain here is 1 plus 3v dx minus 2x and then v dx plus x dv is equal to 0. So if we divide both sides by x, both sides of the equation by x, then x for the first and second term should cancel out. So we have 1 plus 3v dx minus 2 times v dx plus x dv is equal to 0. Okay, so next we must distribute 2 so that we can combine all the terms containing dx. So 1 plus 3v dx minus 2v dx minus 2x dv is equal to 0. So combining, so 1 plus 3v minus 2v, so that will become 1 plus v dx, and then minus 2x dv is equal to 0. Okay, so next, to separate the variables, we can divide both sides of the equation by 1 plus v and x. So dividing both sides by 1 plus v multiplied by x, so also on the other side 1 plus v x, so this will become 1 plus v dx over 1 plus vx, so this will become dx over x minus x will cancel out, this will become 2v over 1 plus v is equal to 0. Okay, so now we can integrate each term. Integral of dx over x minus integral of 2v over 1 plus v. Oh, sorry, this is 2 dv. Right, so cancelling out x, so 2 dv over 1 plus v. So this will become ln of x, okay, minus 2 ln of 1 plus v is equal to, so we can so integral of okay, so after integrating, then we have a constant of integration c. Okay, or we can just, or we can express it as natural logarithm also, so that we can combine all of them. So ln of x is equal to ln of x minus 2 ln of 1 plus v is equal to ln of c1. So if we say c is equal to ln of c1, so then we can simplify it as using the rules of logarithm. So this will become ln of x minus ln of 1 plus v squared is equal to ln of c1. So combining this using the quotient rule, so we will have ln of x over 1 plus v squared is equal to ln of c1. Okay, so therefore x over 1 plus v squared, 1 plus v squared is equal to c1. Okay, so that is the solution, but we still need to return to the original variables. Okay, so since we have substituted y is equal to vx, then therefore, since y is equal to vx, then, so again, since y is equal to vx, then v is equal to y over x. Okay, so substituting that back into our answer, so we will have x over 1 plus y over x, right, squared is equal to c1. Okay, so if we simplify that, so that would be x over 1 plus y over x, so that would be equal to x plus y over x squared is equal to c1. So then that will become x over x plus y squared over x squared is equal to c1. Okay, so therefore dividing this, so x divided by x plus y squared over x squared, so that will become x times x squared over x plus y squared is equal to c1, or x cubed over x plus y squared is equal to c1. Okay, if you don't want any fractions in your final answer, then x cubed is equal to c1 times x plus y squared. Okay, so this is our the simplest form of our solution. Okay, so since we are not given with any values of x and y, so then we cannot solve for c1, so therefore this is a general solution. Okay, so that's it. So let's have another example maybe. For our second example, so find the general solution of xy dx minus x squared plus y squared dy is equal to 0. Okay, again, in solving ordinary differential equations, so first, solution we try if it could be solved using separation of variables. So this cannot be separated, okay, because we have here we cannot factor this one. Okay, so therefore we can't separate x and y in here. Okay, so therefore if it cannot be solved using variable separable, then we inspect if it is the homogeneous type. Okay, so in the homogeneous type, so again, the degrees of the coefficients, the degrees of the variable coefficients must be the same. Okay, so here the degree of x is 1, the degree of y is 1, so total degree of x and y is 2. Okay, so here x squared, its degree is 2, and then y squared, its degree is 2. So therefore it is homogeneous. Okay, so it can be solved using the homogeneous type. Okay, so for our solution, so again we will substitute y is equal to vx or x is equal to vy, so depending which one will give us the easier solution. So by inspection, we can see that the term dx here has simpler coefficients, so therefore it is easier to use the substitution x is equal to vy. Okay, so therefore dx is equal to v dy plus y dv. Okay, substituting, so x is equal to vy times x, so x is equal to vy, and then we have y, and then dx is v dy plus y dv. Okay, minus, we have x squared, so x is vy, so vy squared plus y squared dy is equal to 0. So again, before we do anything, let's work on canceling at least one term. So if we simplify this will become vy squared times v dy plus y dv minus, so this will become v squared y squared plus y squared dy is equal to 0. So as we can see here, we have a common factor here of y squared. Here we also have y squared, so we can cancel out y squared by dividing both sides of the equation by y squared. So but first, by factoring, so we have v y squared times v dy plus y dv minus, factoring out y squared, so we will have v squared plus 1 dy is equal to 0. So dividing both sides with y squared, the other side also, so then we can cancel out y squared. Okay, so we can cancel out y squared here and y squared there. So distributing, so that we can combine the terms with dy, so this will become v squared dy plus vy dv minus v squared plus 1 dy is equal to 0. Okay, so if we combine v squared, so we have v squared minus v squared minus 1, so we will be left with negative dy, right? So vy dv minus dy is equal to 0. Okay, so by separation of variables, so we can divide both sides with y. So vy dv over y, so that will become v dv minus, this will become dy over y is equal to 0. So now integrating both sides, since we have separated the variables already, so this will become integrating v dv, that will become 1/2 v squared minus ln of y is equal to, so since we finished integrating, so it's equal to a constant c. Okay, and then we can let c is equal to ln of c1, so that we can combine the terms with the natural logarithm. So this will become 1 over 1/2 v squared, we can transpose it, the ln y, so this will become positive ln of y plus c will be ln of c1. So therefore we will have combining 1/2 v squared using the laws of logarithm product rule, so this will become ln of c1 times y. Okay, so since v, from our substitution, since x is equal to vy, then v is equal to x over y. So we can substitute that back, so we will have 1/2 x over y squared is equal to ln of c1 y, or simplifying, so this will be x squared over 4y squared is equal to ln of c1 y. Or if you don't want any fraction, so you can cross multiply 4y squared on the other side, so we'll have x squared is equal to 4y squared ln of c1 times y. Okay, so this is still a general solution. Okay, so again, all you have to do with all you have to remember in dealing with homogeneous differential equations is that first you will select the right substitution that will make the solution easier. Then after the substitution, you should cancel out something. So something should be cancelled out after the substitution, and after the simplification, it should become variable separable. Then once you have arrived with the answer, okay, or the solution, then you express v back into the original variables. Okay, so that's all, and good luck. Sorry, there has been a mistake. So 1/2 here is not included in the squared, so it should only be 2 in here, and then 2 there. Okay, so therefore, we are rewriting the answer. It should be x squared is equal to 2y squared ln c1y. Okay, so sorry.